Hello students, welcome to the online class of computer applications on behalf of Southern School affiliated to ICSE New Delhi. Today our lesson is the discussion regarding steps of Java program execution. Okay, you know the Java program is not executed directly by the CPU of a system. There are some steps. Okay, so today we will learn those steps. So as you can see here, this is the diagram or flowchart of Java program execution. Okay, so as you can see, this is a big flowchart, a lot of steps involved in it, and here it is, the figure steps of Java program execution. So to learn in detail about these various steps, you need to know about source code, bytecode and machine code at first. Once again I am telling source code, bytecode and machine code. So three types of codes are there in this program execution, Java program execution. So you need to learn it at first. So at first, source code. So what is the definition of source code? It is a set of instructions and statements written by a programmer using a computer programming language. Okay, so whatever the program will be written by us is actually the source code. Okay, and now the bytecode. What is bytecode? It is an intermediate code of program execution which is obtained by compiling the source code. It is a low level code which is used to generate machine code with the help of interpreter. Okay, so bytecode is generated by compiler, and from bytecode machine code will be generated with the help of interpreter. And now the machine code. It is a set of instructions written in machine language that can be executed directly by the CPU. Okay, so ultimately we want this. Okay, the computer system want this machine code to execute. So directly a program, that means the source code, will not be executed. The source code will be converted to bytecode at first, and then the bytecode will be converted to machine code, and then the CPU will recognize this machine code. Okay, so CPU will not recognize source code or bytecode. CPU will recognize machine code to execute a program. Okay, is it clear? Now let's get back to the diagram. So at first, as you can see here, the first step is create or edit the source code. That means we need to write the source code using Notepad or any IDE like BlueJ, Eclipse, NetBeans. Okay, and whenever we will create the source code, that source code will be stored on disk. Okay, so right now the source code is stored on disk. Now this source code will be compiled by the Java compiler, which is named as Java-C. So Java-C is the Java compiler that compiles source code and generates bytecode. Okay, this bytecode, so before that I want to tell you that the source code, the extension of source code is actually .java. Okay, so .java, and whenever the source code gets converted into bytecode, the extension is .class, and this bytecode is platform independent. Means this code is independent of the machine on which the program is run. This makes a Java program highly portable. That is, the bytecode can easily transferred from one system to another system. Okay, so that's why this is platform independent. It can run on any platform. That means on any machine having different types of operating system. Okay, like a machine that runs with Windows, a machine that can runs on Linux. So in every operating system this bytecode can run. So after that, when this bytecode is run on any system, an interpreter that is known as JVM is needed to translate this bytecode to platform dependent machine code. So what is the role of JVM? JVM translates this bytecode into platform dependent machine code. Okay. Now the machine codes are platform dependent. The machine codes are platform dependent as the machine codes for different platforms are different from each other. For example, the machine code for a system with MS-DOS operating system is different from the machine code of a system having Windows 7. Okay. So the JVM converts this bytecode to machine code accordingly. Okay, like for example, if I show you, suppose this one, if suppose bytecode is run on MS-DOS based machine, then the JVM will generate machine code for MS-DOS based machine. If the bytecode is run on Windows based platform, then the JVM will generate machine code for Windows based platform. Okay, so same thing happens for Mac platform, and same thing will also happen for Linux platform. Okay, so machine code is platform dependent. Now this machine code, when this machine code will be generated, CPU can directly execute this machine code. Okay, because this machine code is written in machine language, machine's own language. That's why CPU can directly execute this machine code, and it can produce output. Okay, and the output will be produced. Now two things you need to remember here. When the source code is compiled, and if there is any error in your source code, then bytecode will not be generated. Then what will happen? That means some compilation errors occurs, like syntax error. Okay, that's why what will happen? You have to get back to the initial step, that is to edit the source code. That means you have to correct your source code. You have to edit something to correct your source code. And when the source code will be corrected, then the source code will be again compiled, and if there is no error, then only the bytecode will be produced. Okay, and same thing happens in case of output also. While when the CPU will execute the machine code, then if there is any error occurs at that time, that means the runtime error, those type of errors are known as runtime errors. Or suppose any wrong output is produced. Suppose you want the output 6, but the output came like 1, that means wrong value. Then what will happen? That means your program is not correct at that moment. That's why again you need to go back to the initial stage to edit your program. And whenever you will edit your program, you will correct those mistakes. Then again you need to go through these steps to produce the correct output. Okay, so that's all about the steps of Java program executions. Okay, so once again remember the steps. At first source code will be created, then the source code will be compiled by the Java C compiler of Java, and bytecode will be generated, which is platform independent. And then the bytecode will be converted into machine code, which is platform dependent by JVM. Okay, it will be converted by JVM, which is called the Java interpreter. Okay, so Java uses compiler as well as interpreter, where interpreter is actually the JVM, and it is known as Java virtual machine. Now why it is known as Java virtual machine, I will discuss later in this lesson. So after that machine code, whenever the machine code is generated, then the CPU executes that machine code to produce the desired output. Okay, I think it is clear to you. So now one question may be asked to you, that why the Java interpreter is known as JVM. Java interpreter means this one. Java interpreter converts the bytecode to platform dependent machine code. Okay, so why it is known as Java virtual machine or JVM? So I am writing the answers. The machine codes for different platforms are different from each other. Okay, so the bytecode needs to be modulated according to the machine, isn't it? According to the machine on which it is to be executed. Just like if the bytecode is executed on a MS-DOS based machine, then the JVM should generate the bytecode, generate the machine code for MS-DOS based machine, isn't it? And for Windows based machine code. So the Java interpreter acts as a machine to generate machine code for specific machine from the bytecode. Okay, but we know that the Java interpreter is a software, that is virtual or logical in nature. Okay, virtual or logical in nature, that means the Java interpreter does not really exist. We cannot touch it. Okay, so virtual and logical in nature. Hence, overall, it is referred to as Java virtual machine. or JVM. So that is the reason. A software that acts as a machine, that's why Java Virtual Machine.